Hi all, myself Sahanashri from 3rd year ECE and I welcome you all to this video explanation of a problem from network theory. There are three problems and this is the first problem. So here is the problem statement. So let us go into the problem. Here is a circuit given below. In the following circuit, the switch is closed at t is equal to 0. And what is the initial value of current through the capacitor? So what they are coming to say is that here is a switch, right? Here we can see a switch here. So the switch is to be closed at the time t equal to 0. So before that, for a long time it may be open. So the time that they have been open, it is not mentioned. So at time t is equal to 0, the switch is being closed and our task is to find the initial value of current stored in this capacitor, and also they have not given the value of capacitor. Also inductor value is not provided, right? So yeah, let us analyze this circuit first. So since they have asked us to find the initial value of current, so I think this such circuit comes under steady state analysis. So because before the switch is closed at t is equal to 0, the switch may be open. We don't know how much how, uh, how how long the switch is closed, right? So before the switch is closed at time t is equal to 0, maybe some amount of current might be stored in the inductor. Also some voltage would be stored in the capacitor, right? So yeah, so I think it comes under steady state analysis, like that is transient analysis. So here it is given that 12 volt supply is given here. So no AC components, like no alternating components, alternating current or anything is given as supply to this circuit. So it comes under DC uh, transient analysis. So yeah, let's try to solve this. At time t is equal to 0, when the switch is closed, the circuit becomes like this, right? So yeah, uh, initially no current will be flown through the inductor, and also the capacitor's voltage would be 0. Yeah, right? So we know the basic characteristics of an inductor and capacitor, right? The capacitor stores voltage, right? Initially in a circuit, the capacitor will not contain any voltage. So let us assume like that here. When the switch is closed at time t is equal to 0, the voltage across the capacitor would be 0, so the current also is 0. Let us assume here. Also the same assumption for this inductor too. When the switch is closed, the circuit becomes like this. So we are going for KCL. Here I am using KVL, Kirchhoff's voltage law, for solving this circuit. Might be there are many methods, but for easier purpose I am using KVL here. So as you all know, we have to write loop equations in KVL. I am mentioning the current directions here. As there are three loops, I'm giving I1, I2, I3 as the current flowing through the loop in clockwise directions. You can take the current directions in current flowing directions in any kind of directions, like clockwise or anti-clockwise. So here I am checking all the currents are flowing in same directions, that is clockwise. And now I am applying KVL here. This is the loop 1 equation and loop 2 and loop 3 equations. All the equations I have separated I1, I2 and I3, and after finding and evaluating the all the three loops equation, I am trying to solve. I'm trying to minimize the equation by substituting equation 2 in equation 1. This is the equation 2 of loop 3. Since we have to find the current flowing across the capacitor, I am using equation loop 3's equation. I'm taking loop 3's equation as equation 2 and substituting in 1. After that, we are getting like this much of steps. I hope you understand this. And since we need I3 current, because here the capacitor is in the loop 3, I am finding loop 3's current, right? um, and yeah, after finding I3 current, I'm using Ohm's law, V is equal to IR, for solving the problem. And yeah, the final solution is 1.6 amps. I hope you understand. Thank you for watching.